Hi folks, this is Dr. Mughal here, and today I'm going to give you a short tutorial on one of the term projects for the sensors, signals and system EC 2019. This project is about hardware interfacing, acquiring data from iOS and Android sensors. I'm assuming most of you have smartphones, and believe it or not, if you have one of those smartphones, you have at least 5 sensors in your pocket. And those are acceleration sensor, angular velocity, orientation sensor, magnetic field, and position for GPS, gravitational positioning systems. So how would you get started on it? Before I get started, the whole point of doing this project is we are going to make sure all those 5 sensors are working properly. We're going to log data from all those 5 sensors, and we're going to retrieve that data wirelessly and import it into MATLAB. And then using those log data, we are going to create plots. So at the end of the day, you will get something like this in one plot each for each of the sensors. And that will all these sensors, they are relative to X, Y, and Z axes. So you see a plot something like this. So how would you get started on it? The very first thing that you need to do here is you need to install the MATLAB mobile application to your device. So if you have an Android, go to Google Play Store. If you have an Apple, go to Apple Store and find the MATLAB mobile and download that application. It doesn't take too long. The second step is you need to install MATLAB 2014 or above on your laptop. I really encourage you to do this on your laptop using the private Wi-Fi network. For some reason, it's a lot more easier to connect your cell phone with your laptop using the private Wi-Fi network versus public Wi-Fi network or using desktop, any of the computers on campus. So really, you could do this project from the comfort of your bed. You don't necessarily have to be on campus. As long as you have the laptop and smartphone and a Wi-Fi network, you should be able to do it at home. So second step would include installing the MATLAB 2014. Being a WPI student, there are different ways to use MATLAB. At WPI, it can be installed on your personal machines or accessed remotely using a terminal server. I encourage that you go to, there are 2 links here. You go to this link. This will require you to create a MathWork account via the MathWork. Click on download, and you should be ready to go. You don't have to pay anything. It's free for all WPI students. Number 3, so when you install MATLAB, you will have to go to, let's see, where is it? Add-ons, and you need to go to check for updates and click on hardware support packages. And here, to see all, so we go to home tab and select add-ons or manage add-ons. Okay. Since I have already installed on mine, so again, if I go here, okay, add-ons. Okay, MATLAB. Here you can actually type iOS, enter. Okay, here's the MATLAB support package for iOS sensor. You click here and you can install it by clicking on this button. I'm actually gonna go back. If you have an Android phone, you type Android here, enter. So MATLAB support package for Android sensors. So depending upon what kind of phone you got, you need to install the support package for Android or Apple. Once you have done that, okay, so this support package enables you to collect sensor data from your iOS device or Android device, and log it in MATLAB, and that's what we are going to do. So wirelessly getting the data from your cell phone, plotting it on MATLAB. When you finish installation, opening this file right here, this one right here, from your operating system, or from within the MATLAB by navigating the current folder to the location of the downloaded file and double clicking it. Anyhow, when you click on it, when this should automatically pop up. When it does, you need to click next, and then after that you click install, and then once the installation is complete, click finish to complete the installation. And hopefully then you should be done with all the software or add-ons that you needed. This project actually requires very basic knowledge of MATLAB. So if you're not really familiar with MATLAB, you don't have to worry about it. I'll try to explain as much as I can. So I have MATLAB installed on my, so this is the command window here, right here. And this is the workspace, and these are the folders that tells you, like, so I'm in this folder right here, and it basically tells you a link where your file is being stored. Whenever you create a file, your coding will go over here, and you have to make sure that when you name a file, there's no space between them. I suggest that you don't use any special characters. Just go with maybe your last name underscore project1 or something like that. Okay. All right. The first thing after that, when in terms of coding, what you need to do is you actually need to use this command connector on space your password. So you need to replace your password with your password. Again, that could be, for example, your last name. So connector space on space your last name. So basically what you are doing, you are going to give your cell phone, whether Android or iOS, you are going to give it some name, some identity. Okay, and in order for that, you need to set up a password first. So connector space on space your password. Anything that you see here that is underlined is the code. Okay. Yeah, so this is underlined, so this is the code. The percentage sign basically is used for commenting in MATLAB, and then each line you should have a semicolon. That means this is a line break, and then you move on to the next line. Okay, after you execute this command, the following information will be displayed depending upon the configuration settings of your computer. This is just for example. Okay, so it's gonna, when you say connector space on space your password, whatever you said, it's going to return you this information right here. Okay, this is important because you're going to use it. Okay, if the test is successful but MATLAB mobile cannot connect, your computer might have multiple IP address, something that I was mentioning earlier. To determine the correct one, see determining the DNS name or IP address of a computer. Okay, once you have this information available, what are you going to do? You are going to go to the MATLAB mobile application. And when you open that application, it will look something like this. Okay. Great. Go to MATLAB mobile application, tap more settings, which will be somewhere over here at the top right, bottom right of that app. Click on tap settings and then add a computer. Add a computer, enter the IP address from here into this field right here. So your IP address will go over here. And connector password. Connector password goes here that you had set up over here. Okay, so IP address goes here, password goes here. Once you have added those two pieces of information, you need to connect. All right, and this establishes a connection between the two devices, your laptop and your and the cell phone. Okay, once you have the connection established between your cell phone and your laptop, we have to create a link to your mobile device. Then again, we are going to use this command, m equals to mobile device. This is a command that is used. and then M is the name of the device. So you're basically giving your cell phone identity, and the name of that your cell phone is basically M. So it could be again your last name or whatever. When you execute this command, it will create an object that reads sensor data from a mobile device connected to the same network as the computer running MATLAB. Following information will be displayed. Okay, one thing that you need to make sure is that turn your data plan off on your cell phone, and have your laptop and your cell phone connected to the same Wi-Fi network. Okay, otherwise this is not going to work. So again, when you write this, in the command window, which is actually right here, you write here. Let me move this around. Yeah, when you write M equals to mobile device semicolon, and you press enter here, it is actually going to give you this information. Yeah. Okay, so this basically tells you the status of your sensors right now. You have been connected. One means that there's a connection between your cell phone and laptop. Logging 0 means you're not logging data yet. And this is the initial timestamp. This would tell you later on we'll be using this in order to get the real-time data, that at what time you started logging data and what time you stopped logging data. Like I mentioned, there are 4 sensors. 0 means they all are disabled at the moment. Okay, so all 4 sensors, actually 1, 2, 3, 5 of them, all 5 of them are disabled right now. The displayed output should show connected 1, indicating that the mobile device object has successfully established a connection to the app, which it does over here. If for some reason it tells you 0, that means the connection hasn't been established between your cell phone and your laptop. Okay, now preparing for the data acquisition from multiple sensors. Since you have 5 of those and you see them over here in your app, when you click on sensors, we go to more and you click on sensors, those sensors will appear over here. So this is the acceleration sensor, this is the magnetic field, orientation, angular velocity, and location used for GPS. There are 2 ways you can actually enable these sensors. One of the most easiest way is to just tap on these icons right here, all 5 of them, and you will see they will be enabled. Once you tap on them, they will be enabled like this. So it looks like the acceleration is and angular velocity is enabled. The rest of the other 3 sensors are disabled, but you make sure that you enable all 5 of them. So go to mobile application, tap more, tap sensors, activate all 5 sensors by tapping the sensor icon at the top row, see figure 2. Other way of doing it is basically using these commands. Okay, so again, M is your device name that you had initially set, M equals to here in this. If you're using your last name here, let's say you have Fernandez as your last name, equals to mobile device, and you should say Fernandez dot angular velocity sensor enable equals to 1. Okay, so all 5 sensors need to be equal to 1. Okay, now next step would be control sensors and start acquiring data. After enabling the sensor screen of MATLAB Mobile will show the current data measured by the sensors, see figure 2. So as soon as you enable these, it will start showing data relative to X, Y, and Z axis for all the enabled sensors that you can also see. And as you move your cell phone around, you'll see, in situ change in these numbers. And this is exactly what we are going to plot using MATLAB. Okay, the logging property allows you to begin sending sensor data to mobile device. Okay, then we are going to use this command m.logging equals to 1. Okay, the device is now transmitting sensor data. A pause is included to allow for some measurements to be made before moving to the next steps, but is not required for logging to occur. So if you want to use this command, I encourage that you do it. Even if you don't do it, that's fine. Then you use this command display m. This basically what it does, it looks at the object now that you have started logging data using the display function. Okay, so now you are logging data because you have m.logging equals to 1. Okay, at the start of the logging, the device is lying flat on a table with the screen facing up. The positive y-axis of the angular velocity sensor is defined to extend out from the top of the device. Positive roll of the orientation sensor is defined as a clockwise rotation, and about the y-axis when facing the positive direction of the x-axis. So you basically can have a look at it, like how would you move your cell phone in your hand, that you changing the three-dimensional positions of the data for sensors relative to these three axes, x, y, and z. So what you do when you start logging data, you have your cell phone face up, and then just try to move around a little in your apartment or your house. Try to log data for maybe 3 to 5 minutes. Shake your cell phone, uh, throw high up in the air, don't break it. Just play with it, for 3 to 5 minutes as you are logging data. During logging, after roughly logging for 5 minutes, during logging, the device is turned face up and face down a few times about its y-axis. This generate y-axis changes in angular velocity and roll changes in orientation. See figure 3. Once you 5 minutes have elapsed and you want to stop logging the data coming from the sensors of your cell phone, you want to use the command m.logging equals to 0. Again, that m is the device name, and 0 is basically you're disabling the logging now. Now, the data needs to be retrieved now. The logging part is done. We are going to retrieve the log data. Each sensor data can be accessed from the mobile device object, and two different time stamp variables are created because the angular velocity and orientation data may not be recorded by the device at the same time. Okay, all right. Now, these commands, I'm going to show you, I'm going to explain what these commands are doing here. Okay, this is an array. Okay, we are creating an array, and we have created 5 arrays, one each for each sensor. What this AV is doing, this is just a variable AV. This could be anything. You can write angular velocity. This could be orientation. This could be acceleration. This is just a variable. I went with AV. All the data which is being logged in was going into this variable AV, x-axis, y-axis, z-axis, all the data. TAV is a time. Okay, so we were taking data for 5 minutes. So whatever data for 5 minutes that goes in there, the timestamp that goes in there. Similarly, TAV, T0, TAC, TF, TL, all these are same. They just have different variable name, but since we are logging and we had all these 5 sensors enabled at the same time, so same data that goes in there. The orientation data from the orientation sensor goes in variable O. The data from the acceleration sensor goes in here, and similarly for magnetic field and position goes into these variables. Okay, so what we are saying here, the angular velocity log of M, this returns the log angular velocity data for device M. Okay, remember, if you are using your last name as a device name, so you need to replace M with your last name. For orientation log, this is the command. For acceleration log, this is the command. This returns a logged acceleration data. Now, all the data is saved in these variables: AV, O, ACC, MAC, and POS for position. Okay, now we need to plot the raw sensor data and convert it to absolute timestamps. Okay, so a timestamp would basically means MATLAB has this capability to go into your system and get the real time from here. And then as you were logging the data, it will actually basically tell you what time you started logging the data and what time you stopped. Okay, so basically you should see a 5-minute window if you were logging data for 5 minutes. So data of interest from the sensors are isolated into separate variables and plotted, like I mentioned, in separate variables. Okay. Just go through and read this part. To convert all sensor timestamps into absolute timestamps, the initial timestamp value is converted into a datetime object. I'm really not expecting you to have a really good understanding of this code, but because it's really beyond the scope of this course, but I'll basically go through um, this code right here. So we are now going to plot angular velocity. So this code that you see over here is only for angular velocity. First, we create a variable t initial time. Again, this could be any variable. Okay, MATLAB is a case-sensitive language, so you need to make sure if you're using this variable name, you use it the same way over here also. Okay, all right. This command right here, this command, what it does, it takes whatever the initial time is when the data was logged in and saves in this variable. Okay, now t angular velocity, which is this right here, then we create another variable and we call it t angular velocity, which is equals to whatever the initial time when logging took place plus the amount of time you were logging the data which was saved in this variable TAV. Okay, so we use this time t initial, which is the variable, which is a initial time that was when you started data plus the amount of time you were logging the data, and then you say plot comma x-axis bracket open x-axis comma y-axis. On the x-axis you want to have time. Okay, so if you look at these plots right here, on the x-axis you have time. This is the absolute time. So this gentleman started taking data at 10 o'clock and he took it till 11:15, so he was taking data for almost 1 hour and 15 minutes. Okay, you don't have to take it for that long. Okay, so plot t angular velocity, this is the time, absolute time value when you were logging data, and AV is the variable in which all the log data from an angular velocity sensor was saved. So this is a command. What it does, it's basically plotting angular time versus angular velocity data from your sensor. In order to give a title to your plot, you basically in brackets and in single parentheses you say angular velocity, single inverted comma, you say angular velocity, y label and x label. For example, y label you want to say angular velocity, so that's how you use the command. So if you look at your y-axis here, it says angular velocity, and x-axis absolute time. X-axis absolute time. So this is going to be same for almost all the other four plot, except for the title is going to change from angular velocity to orientation, and for positional sensor it will change to position. So this part of the code was for the angular velocity. Let's now move on to the orientation part. Again, the first line is pretty similar to that of this one right here. Okay, it's doing the same thing. It's taking the pulling the whatever the time was at the time you start logging data, and then adding it to t naught. T naught was the amount of time you were logging data, and then it adds those two values, and then you are plotting it x-axis versus comma y-axis. On x-axis you want time, and then on y-axis you want the orientation data, which is saved in variable O. So you say plot the orient comma O, title orientation, x label absolute time, and y label. So if you look at this one, orientation, this is the title, x-axis absolute time, and y label orientation. Okay, similarly you do it for acceleration and all that. The only thing in this part of the code is changing is the t orient here for orientation, t angular velocity for the angular velocity. Okay, and similarly for, let's now move on to the acceleration data. This line is same as the previous one. You are creating a new variable in which you are storing the initial data and then adding the whatever amount of time the data was logged. from the sensor, and then you're plotting it. So it's pretty similar. You can copy and paste it, and then just change these variable names for different sensor that you used here. Okay. All right. So all the code is pretty much here. Note down the acceleration in all the sensors, all log data in relation to X, Y, and Z axis. Figure 3 shows these axes related to the device. I had already shown you this. I don't have a code here for the GPS positional sensor, but similarly do it for position as well. However, you should have latitude and longitude values on Y and X axes. So for the positional sensor, the X label should say longitude, Y label should say latitude, title should change to position, GPS or position, positional sensor. Plot, this would be same. This would be same. This would be you're creating a new variable, so you can say TMP, time position, and then T initial time, which is right here, plus the variable that you use for logging time for position is TL. Okay. Let me go back and show you one more time. TL. Okay. So you go here and you change from TF to TL. And there's T and the plot now. So T M P for position, comma, the variable with the data saved, which is POS. Okay, so this will change into POS. Okay, and that's pretty much the code. Let me go to the MATLAB here, and I have this project right here actually. This part of the project, when you are trying to connect your cell phone with the laptop, you can basically do it over here. Okay, so I don't know if I don't have it connected right now, but let's see if I have a connector on. Go. Okay, so when I enter, yeah, so when I say connector on Google, it returns me the IP address. This is what I need. That this information will go into the MATLAB mobile app. Okay, and similarly, yeah, M equals to mobile device. Let's see what M equals to. I don't have it connected right now. Okay. So the support package is not installed on mine, looks like. Okay. All right. So here's the code right here. Okay. So same thing over here, and then angular velocity graph. Notice in the graphs, you have these X and Y and Z as legends, their label, which I didn't have in my code right here. Okay, so if you like, you can actually add one line after this line, and that should say legend, in single inward comma X, Y, and Z. Okay, so you can see your X, Y, and Z axis in 3 different colors, like you can see over here. Okay, so here's the full code. Okay, this is a very interesting and very fun project. So I really encourage you to do this. If you have questions, feel free to ask, or come and see any of the TAs. This is going to be due Friday, September 14th. So actually you have more than almost 2 weeks to work on it. And once you finish this project, I would like for all of you to basically compile your code right here. Once you compile your code, you basically yeah, once you have your code ready, all you need to do is basically click on run. When you click on run, it will generate these plots. You can right click on it and then save it in a Word file. You can copy your code from here and paste it into a Word file along with the plots, and convert that Word file into a PDF and then actually upload it on the canvas. With this, I'm going to finish this small tutorial. If you have any questions, please feel free to ask. Okay. Good luck with this. I hope you enjoy this. Bye.